In the rotational dynamics, rotational inertia, center of mass, radius of gyration, preliminary terms. We are going to introduce that preliminary terms. Rotational dynamics. The first term is rigid body. Rigid body. So what is meant by rigid body? A body, a uniform circular motion, angular displacement. The preliminary terms, you are familiar with that. Now in this we are going to study what is meant by a rigid body. Rigid body എന്ന് പറയുന്നത് different masses m1, m2, m3, m4, m5, m6. So all these are different masses. It is distributed in this unsymmetric figure at different points like this. So this body we call by the name rigid body. And you imagine its rotation about this axis. This body is getting rotated about this axis. So this is called the axis about which it is rotating is called the axis of rotation. So this is a mass, this is another mass, this is another mass, this is another mass. Different masses, not uniform, so density is also different. So this body is rotating about this axis, means m1 is rotating at a distance r1 from this axis, m2 is rotating at a distance r2 from this axis, m3 is rotating at a distance r3, like this. The whole body's rotation, if we think individually, each particle in this body is rotating at different axes, different distances from axis of rotation. So what is center of mass? In this figure you can see that 6 masses, m1, m2, m3, m4, m6, 6 different masses distributed inside this figure. If this body is rotating such that whole mass of this body is concentrated at this point, or it behaves like that, the whole mass of the body is concentrated at this point at which whole mass of this ununiformly distributed body is mass is concentrated, we call by the name center of mass. And the distance from the center of mass to axis of rotation, we call by the name radius of gyration. Again, let us revisit. Center of mass is the point at which whole mass of the body is said to be concentrated. Radius of gyration is the distance from center of mass to axis of rotation. It is represented by the symbol K. Next in this, we have to see what is meant by rotational inertia. Linear motion, what is inertia? All of us know that. the incapacity of a body to change its initial state is defined as inertia. The tendency of a body to remain in its initial state of rest or state of uniform motion is inertia. In rotational dynamics, rotational inertia represents the inertia in rotation. Inertia in rotation. So comparing inertia in linear motion, rotational inertia in rotational motion. Comparative study is necessary. Rotational inertia has another term, moment of inertia. Moment of inertia. Momentum of inertia alla, moment of inertia. Moment of inertia or rotational inertia. Inertia in rotational motion. Linear motion, inertia depends only on the mass of the body. We have seen that example. Cycle, car, example or middle. Rotational inertia represented by the symbol I is mk square formula. M is the total mass of the rigid body and k square is the radius of gyration square. So if we can analyze this body as different masses M1, M2, M3, M4, M5, etc., I is equal to M1R1 square plus M2R2 square M1 M1 at a distance R1, M2 at a distance R2, M3 at a distance R3. So like that, M1R1 square plus M2R2 square plus M3R3 square plus etc. For I is equal to sigma mr square, or I is equal to sigma m total mass of the rigid body which is concentrated at the center of mass if we consider as m, sigma r square radius of gyration square. So this is the equation for rotational inertia. So rotational inertia depends on M1R1 square, M2R2 square, the mass of the body and the square of the radius of gyration. Okay, so let us revisit once more rotational dynamics. We know what is meant by rigid body. We know what is meant by axis of rotation. We know what is meant by center of mass. We know what is meant by radius of gyration. We know what is meant by rotational inertia or moment of inertia. We know the formula in analyzation or in general formula of calculation of rotational inertia. Okay.